Last day we introduced the topic of distance time graphs. We saw that we could use a distance time graph to plot the motion of a object throughout a journey. In this case, we saw a car that was moving forward at a steady speed. We saw that because the line was going up in a straight line. It stopped for a second. We saw a horizontal line on the graph, and then it reversed backwards, and it was faster coming backwards. We could tell it was faster because the line was steeper. And we could use the gradient of those lines to work out the speeds. So for that first section, we saw that there was a rise of 12 meters in a run of 3 seconds. So 12 divided by 3 equals 4 meters per second. For B, there was no rise. There was a run of 1 second, which meant 0 meters per second. And then for section C, there was a negative rise, a rise of negative 12, and a run of 2 seconds. So negative 12 divided by 2 gives us negative 6 meters per second. And that negative meant it was coming backwards. Today I want to have a look at a graph that superficially looks the same, but tells us a very different type of information. And that's the speed time graph. So speed time graph, as I said, looks very similar, but the y-axis is speed, not distance. And what it does is it plots the speed of an object as time goes on. So let's consider this car. This car is moving at a steady speed. It's not speeding up, it's not slowing down, and the graph represents that as a horizontal line. We can see that the speed is, in this case, 4 meters per second. It's not getting faster, it's not getting slower, it's just moving at 4 meters per second. So it's a horizontal line. Now, in a distance time graph, a horizontal line meant not moving, but in this case it means not changing speed. It's staying at a steady speed. In this case, the car is traveling at a higher speed, and that's represented in the graph by another horizontal line for steady speed. It's just higher up the graph, in this case 8 meters per second. So remember, horizontal line means steady speed. But as we know, objects don't always travel at a steady speed. What's happening here? Our car starts off very slowly and picks up speed. It's accelerating. So it started off not moving and then gets faster and faster and faster, and the graph represents that with a straight line at an angle. In this case, it went from 0 meters per second up to about 8 meters per second in just over 14 seconds. We could work out the acceleration by using the gradient, although that's not something that we're going to worry about in year 10. It's something that you will do in year 11. In this case, we're getting a bigger acceleration. So it's picking up speed faster, but now it's reached a steady speed. And it's just traveling at that steady speed. We can see that the graph represents that by a first section showing an acceleration, an increase of speed. And then we see a steady speed with a horizontal line. In a distance time graph, that would mean steady speed and then not moving. So don't mix up the two. This is showing speed increasing, then speed staying steady. What about slowing down? In this case, we've got the same acceleration at the start. The car is picking up speed. Now it's moving at a steady speed. And the graph shows that. And then the driver's about to put on the brakes now, and the car comes to a stop. It took less time for the car to slow down in this case. And we can see that in the graph because the downward slope at the end is steeper. The steeper the line, the bigger the acceleration. So we had an acceleration, then we had a steady speed, and at the end we had this negative acceleration or a deceleration. The car was decelerating. So that's a basic introduction to speed time graphs. We'll have a look at our notes, and we've got a few questions for you to do in this as well.